Good morning, friends. In this video of immunology, we are going to discuss about antibodies. Antibodies. See, this is antibody. We all know the basic structure, that it contains two heavy chains and two light chains. See, two heavy chains and two light chains. And the light chains can either be kappa or it can either be lambda. But it cannot be both at the same time. It is either kappa or it is either lambda. And based on the heavy chains, it is classified into various classes, and these are called isotypes, which are the corresponding. See, mu, gamma, alpha, delta, epsilon. Mu signifies IgM, as is starting from mu, right? M, G, alpha for A, delta for D, epsilon for E. So they form the corresponding 5 immunoglobulins: IgM, IgD, IgA, IgD, and IgE. These are called the isotypes. So classes of immunoglobulins vary in heavy chain, especially in constant region of heavy chain. This is called isotypic variation. Next, we jump to the enzymes part. The enzymes which act on antibodies. There are 3 enzymes: papain, pepsin, and mercaptoethanol. And let's discuss about how they are acting on the respective antibodies. First comes the papain. What papain does is that it comes like this and cuts like this. When it cuts, it gives us 3 components. One FAB here, and one FAB here, and one FC here. FAB means fragment antigen binding, which combines with the antigen, and this is the fragment crystallizable containing the heavy chains, basically constant part of the heavy chain. And what pepsin does is that it cuts a bit below here, so we'll get a portion having the 2 FABs joined together, and the concentration of heavy chains are broken into small pieces. And next comes the mercaptoethanol. And mercaptoethanol, what it does, it acts fully on the antibody. So antibody gets broken down into 2 heavy chains and 2 light chains. It's fully broken down. Next, we discuss what a paratope is. Paratope, we heard it somewhere before. We heard that epitope of antigen reacts with paratope of antibody. Paratope is something it is present in the variable region. Where it is present in the variable region, there is a region called hypervariable region, and in that we have paratope. And paratope is said to act with epitope. And we have one more concept of idiotope. And what an idiotope is, that idiotope is the epitope of antibody. What I mean that if you insert the antibody of a human into an animal, then it will develop antibodies against this. Yes, it will develop antibodies against our antibodies. If we insert our antibodies into the sheep body, the sheep will produce antibodies against our antibodies. And then there should be some antigenic portion of the antibody. It is called idiotope, which is present inside the paratope. Next, we jump to the 5 classes of antigens. That is IgG, IgA, IgM, IgD, and IgE. The first one which we are discussing is IgG. IgG is said to have highest DHS. What DHS is? D stands for daily production, H for half-life, and S for serum concentration. And the order of DHS is said to be Gamde. IgG, IgA, IgD, IgE. We'll study that in the subsequent chapters, but for now you just remember that G has the highest DHS component, and it is responsible for 3 things, 3 tests. Just remember it as P, N, and C: precipitation test, neutralization test, and coagulation test. And it binds to 2 things which eat. One which eats and one which kills. The first one is phagocyte and the second one is natural killer cell. And of course, it's bind to a classical complement pathway. And we have an order for binding of classical complement pathway, which is IgM, next IgG3, here IgM, IgG3, IgG2, and IgG1 and IgG2. And 2, it has a least binding effect and it almost said to be not binding. And it is secreted in the placenta and the breast milk. But IgG2 is not secreted in the placenta. We have to remember that. As I told you before, it also acts in the coagulation test except IgG3. And it is late to appear. IgG is said to be the antibody of a late chronic infection or patent. It can be present during chronic infection or past infection. How will you identify whether it is a chronic infection or a past infection? Based on the avidity test, IgG avidity test. What will happen to a bond with the passage of time? It will get strong or it will become weak. Of course, with the passage of time, our bond becomes very strong. Very strong. So, in chronic infection, the bond will be not that strong, so it is low, the avidity is low, whereas in the past infection, it will be very, very strong. Next, we come to the IgE antibody. And IgE is the antibody that is only heat labile. It is sensitive to heat. That's why I gave it a heat color, that is orange. And it is the lowest of DHS. As I told before, the DHS order is GAMDE, G-A-M-D-E, IgG-A-M-D-E. And IgG, it is specific for allergy, hence you already know that E for allergy. So it is responsible for hypersensitivity type 1 reaction. It is responsible for hypersensitivity type 1 reaction. And what will annoy you? A bacteria, virus entering inside body which is not visible, or a worm which is quite visible entering inside your body. Of course, the worm will be more annoying, right? So you'll produce more allergy towards it. You'll produce more IgE towards it. That is, it increases in parasitic or helminthic infection. It is also called Reage-in antibody. Reage, just imagine that the worm name is Reage and it is entering inside. So Reage-in antibody. And homocytotropic antibody. Homo-human cytocell tropic antibody. It is entering and your cell is becoming tropic. Homocytotropic antibody. We come to the next anti-immunoglobulin, the IgD. IgD is said to have the highest carbohydrate content. And how will you remember that? D, right? So it is close to C and E. But as far as the spelling of carbohydrate, CROBHHYD, D is coming first, right? So carbohydrate is excessively present in IgD. It is highest CHO content is present. And it is a surface antigen, as I told you before. The surface, mud in the surface, right? M and D. IgM and IgD are present on the surface of B lymphocyte. Next we have IgA, the secretory immunoglobulin mainly. Second highest for DHS, as we studied in the GAMDE. And next, it can be both monomeric and dimeric. It is single when it is present in the serum. But in the mucosa, it will stick together. Right? Mucosa, sticky, secretory IgA, it is dimeric. Here is the diagram of it. There are two antibodies sticking together with the J chain. But J chain is not the only one which is connecting the two antibodies together. We have secretory chain, which is synthesized by mucosal epithelial cell, and of course everything else is secreted by the plasma cell, but this secretory chain is synthesized by mucosal epithelial cells. And next, the famous IgM comes into action. IgM, the pentamer, very famous one. It has 5 things together like this. It is a J chain, 1, 2, 3, 4, 5. And it is responsible for agglutination reaction. IgG was responsible for what? P and C, right? Coagulation, precipitation, neutralization reaction, but this is responsible for agglutination reaction. Of course, it is also responsible for this. It also binds with the complement, classical complement, just like IgG, and it has more affinity. IgM is greater than IgG 312. And of course, this is the first antibody, acute first antibody congenital causing first antibody in the infant causing congenital infection, and it is pentameric. The first antibody in the infant is IgM. And next we come to the abnormal immunoglobulins. Abnormal immunoglobulins, from the abnormal B we come to BJP abnormal, right? BJP party in India, you must know this, or just remember BJP, B for BJP. And from the party we go to the politics and the history, and when history comes to shine we remember war, and war is known for prisoners. So we have one more abnormal immunoglobulin disease, that is heavy chain disease. And heavy chain disease, okay, this was in the prison. And of course from the war we remember the soldiers, they used to fight everywhere in each all the field. In the cryoglobulinemia, that is the ice, even if the ice is falling they used to fight, and if a storm was coming they used to fight. So it is Waldenstrom's macroglobulinemia, just the mnemonic for remembering. That is Benz-Jones proteins is abnormal immunoglobulin, and heavy chain disease, followed by cryoglobulinemia and Waldenstrom's macroglobulinemia. Now we need to remember some points of BJP, that is the Benz-Jones proteins. It is synthesized in multiple myeloma. What will happen in that is that it is cancerous plasma cells. The plasma cells becomes cancerous, and after it becomes cancerous it starts producing a lot of immunoglobulin expected. But what happens is that it does not produce a proper immunoglobulin. It produces increased light chains, and of course it is excreted in the urine. See, usually proteins are not excreted in the urine, but Benz-Jones proteins are special, so they are excreted in the urine, and it gets precipitated at 50 degrees Celsius. But if you overheat it